This is a TOC question based upon Turing machines. We are having a Turing machine M and its encoding has been given, based upon which these two languages have been formed, L1 and L2, and we have to comment about their decidability. So let us first understand what these languages are. L1 is giving us an encoding of Turing machines M that take more than 2021 steps on all the inputs, while in L2 they are talking about taking those many steps by the Turing machine, but only on some inputs. So that's the only difference. Here we have all, and here we are having just some inputs. So how can we comment upon this? So let us first understand that what we'll be doing over here is we will try to execute this Turing machine M for at least 2021 steps, 2021 plus 1, so that in this step we will check if it is halting or not. So we will try to execute them on all the inputs of length less than or equal to 2022, and this will be a finite set. Why so? Because if k is the set of alphabets for this Turing machine, then there would be k to the power 2021 possible inputs having length that we require. So that this will be a finite set on which we will be running this Turing machine M for those many steps. Then what will happen as an outcome? We will see that M will take more than those many steps on all the inputs. Now by all here we mean all having length less than that, even more than that. Here by all we mean less than 2021 as well as greater than 2021. So that is all. If it takes more than those many steps on all inputs of length less than. So here we are having a restricted domain. We are saying that if it is taking 2021 and greater steps on this set 1, then it will definitely take those many steps on all the inputs, means set 1 plus set 2 combined. So this is a restricted set. If this is satisfying, then only we will comment about the entire S1 plus S2. These are the two sets of inputs. So if S1, if in S1 all the strings pass, then we will say that yes, it is true that it will take more than those many steps on all the inputs. Otherwise, no, which means we are able to comment either yes or no, if it will happen or it will not happen. And this is what we mean by decidability. Hence, this language L1 is definitely decidable. So L1 is decidable. And in the same way, when we check out for this L2, the only difference is that instead of all strings, we are talking about some strings. If in this set S1, only some strings are satisfying this criteria that they are taking more than 2021 steps, then we will be able to say that in the combined set, in this entire language also, only some strings may be able to take those many steps, which means M will take more than 2021 steps on some input, which means if even S1 is not getting entirely satisfied, then how will the S1 plus S2 both will be? If S1 clears, then S1 plus S2 may clear or it may not clear. But if S1 itself is not getting cleared, then S1 plus S2 will never get cleared. So that is what it is. We are in this case also able to comment after checking for S1 whether it will satisfy on both or not. And why we are checking only on S1? Because S1 is finite, but this S2 is infinite set. We cannot check on this entire set S2. So we are only checking on the S1, and then based upon its result, we are commenting whether it will be possible for both or not. So again, in this case, it is we are able to comment yes or no on this. So this becomes decidable again. So L2 is also a decidable language. Hence, we will be going with the option first, that both L1 and L2 are decidable. So that is correct.